Now, to understand how the evolution of the computer has come about and how come it's so powerful today, what we have to discover is how those processing units have become more powerful. Sure, you could store 8, 16, 32 or 64 bits in memory, 64 ones and noughts. However, they're just magnets on and off. The real magic comes with your processing units. Your processing units have now become more evolved because they can process a lot more ones and noughts, giving you more range. Let's demonstrate this by understanding the difference between, let's say, 8-bit and 16-bit, and just see how 8 more bits makes a much larger range, and therefore your computer becomes more powerful when it can process more bits. So now let's limit ourselves to an unsigned 8-bit system. And what I want to do is find out the possible combinations of ones and noughts that there are. Well, remember base 10, how we have units going from 0 all the way to 9. That gives us 10, not 9, 10 possible combinations of our units, 10 choices to choose from. Well, likewise, with an 8-bit system, you have 0, which is a possible combination, all the way to 255. So you go 0 and then 1 and then all the way through to 255. That gives us 256 possible combinations of our ones and noughts on an 8-bit system. Whether it be signed or unsigned, you have 256 possibilities. So now that we understand how many possibilities there are, 256, let's take a look at our processing units. Let's say our processing units are only capable of processing 8 bits, whether that be a GPU, an SPU, or a CPU. They are all 8-bit processing units. Now let's start with the GPU, the graphics processing unit. Now when you send a number to the graphics processing unit, with 0 being the color black and 255 being the color white, and any possible number between those 2 points will produce a different color, red, green, blue, and so forth. So we have 256 possible colors. So that's what happens when we send our bits to the GPU. Take a look at this image that I've just popped up on the screen. This image requires millions of colors to render the image. But what if this was a really old computer like your arcade games and so forth, and they only had 8-bit GPU processors in them? What would this image actually look like? Well, all I have to do is I have to render this image as an 8-bit image, and that will give me an image that looks very blocky, that looks very outdated and old. And you can see that it's not rendered correctly because this image, like our eyes, can render millions and millions of colors. The issue is that this image can only be rendered via 256 possible color combinations. Now on an 8-bit system, let's move on to the SPU. So we have 256 combinations of our ones and noughts. And when you send your ones and noughts to the SPU, it produces a sound wave. Now, our ears can listen to a whole variance of sound waves, but 256 is too low to replicate real sound like you're hearing right now. So if you can remember those really old arcade games that you've seen in the 80s and 90s in those films, you hear the noises that they make and they sound very tinny. And the reason why they sound very tinny is because you only have 256 possible combinations on an 8-bit arcade computer game, and so that's why it sounds like a tin can. Likewise, you have the CPU, the core processing unit, and let's say this arcade again has an 8-bit CPU. Well, likewise, let's say what happens when you shoot all these enemies and so forth, and you get a point for shooting your enemy. Well, you keep adding one from 0, but eventually you're going to hit a ceiling on an 8-bit system, which of course, as you know, is going to be 255, that's the number. We still have those 256 possibilities going from 0 to 255, but the maximum score right there, the maximum number, would be 255 on an unsigned 8-bit system. So in lieu of that fact, what you'd have to do at that point on that arcade game is you would either have to stop or you'd go to the next level. And if you carried on going to the next level, you would end up with 255 levels, max, and then you couldn't go over 255 levels. So there was limits, there was ceilings with 8-bit. And likewise, there's ceilings with any bit system, whether it be 8, 16, 24, 32, and you can keep going up to 64, and you can keep going on from there. But there'll always be a ceiling, but the ceiling gets higher, meaning there's more range, there's more possibilities for colors, for sound, and for processing, such as your numbers. So now, take your 8-bit system, which we know they're primary numbers. We go from 1 to 128, and then add 8 more boxes and keep doubling. And you will eventually end up at 32,768 in the last most significant bit on the left-hand side, don't forget. And then, once we have this, now we need to find out, let's say, the range. And I want to find out the range of an unsigned 16-bit system. Well, you start at 0, and then you would set all the bits to 1, and add all those primary numbers together, and you will end up with 65,535. So you can go from 0 to 65,535. There's your range. Giving us, don't forget, 0 is a possibility, 65,536 possible base 2 number combinations, because you go from 0 all the way up, just like we did with the 8-bit system. So can you now see, by having just 8 more bits, we've raised the ceiling massively. We now have much bigger numbers that we can work with, and much more possibilities. So for example, previously we only had 256 colors on the GPU. Now on a 16-bit system, just 8 bits more, we have the choice of 65,536 colors on the GPU. And likewise with the SPU, the sound processing unit, we can now make 65,536 sound waves, making the sound a lot more realistic. And you also have 65,536 binary numbers that you can work with in your mathematical calculations, meaning your mathematical equations that you run on the CPU can work with larger numbers and a broader range of numbers, making it much more effective for calculation. So this is where we understand that just by adding 8 more bits, it becomes so much more significant. It gives us so much more power. And now when you consider 64-bit processing is even in your smartphones and tablet devices. So you can see the potential and how much you really can do just by adding a few more bits.